Hey geotrig, this is solving log equations day 1. We're going to go real easy today again, just like yesterday with the change of base. Today we're actually just going to solve log equations where you have a log of something, some base. Actually, I should have put base in here. Base is log base b of something equaling log base b of something. The biggest thing that you got to take from here is that those bases are the same. If they are the same, it's going to be really simple. So let me start off with a little bit different equation. Now guys, remember that we talked about how logs are the same thing as exponents in a way, right? It's a roundabout way. We switch them back and forth between exponent form, log form, things like that. Well, if I pose this particular question, 2 to what power would equal 2 to the third power? We already did these types of problems. And you'd be like, well, wait a minute. The only way for these two problems to be exactly the same is if they have the same base. Great. That means they have to have the same exponent. So you guys would be like, oh, x equals 3. Of course. It's the only way for having two things to be the same is as everything in their same exact locations has to be the same. So let's think back up to here. It's log with the same base of something equaling a log of some base equaling something. The bases are the same, so therefore, whatever's inside this space has to equal that space. It's as easy as that, and then you can solve. So it's obviously going to get a little bit trickier than that, but that is the premise of this particular lesson. So let's take a look. I have two separate equations. I got two of them that are fairly easy. First one up is log base 2 of x equals log base 2 of 3. Essentially, because the bases of these logs are the same, I can ignore them. I can say, hey, I can just get rid of them, and I can say x equals 3. What's inside this log is equal to what's inside that log. And it happens to solve. You got x equals 3. Done. Now, the next one, a little bit more stuff in here. That's an x minus 2. That's a 2x. Well, guess what? Don't fret. It's the same thing. I've got log base 3 of x minus 2 equals a log base 3 of 2x. They're the same logs. Let's just cancel them out. When does x minus 2 equal 2x? And now you're probably thinking, I've actually solved this well back in Algebra 1. I can subtract x from both sides. I get negative 2 equals x, and boom, I get negative 2. Now, we're going to leave it there for now. There's a reason this will not actually work, and we're going to get there in a second. But, I just kind of made this up. This does not work. And I'm going to go back into this on the next one, because the whole idea here, maybe I should just talk about it now, is the fact that when you go to check, because we always should check, if I check negative 2 back into my equation, you'll have negative 2 minus 2. And that is negative 4. Which really does mean that you have to do log base 3 of negative 4. And if you do log base 3 of negative 4, it doesn't work. And so, if you think about this, logs are exponents, so it equals some number. It's saying 3 to what power would equal a negative 4? Well, here's the problem. You can't take a positive base, bring it to a power, and make it negative. It does not work. So in this particular problem that I just gave you here, it's flawed. The idea works, and there's going to be problems that they're going to do here that do not have solutions. Or there are multiple solutions, as we're going to get to our next problem, that you have to check all of them. And if you don't check them all, they very well could lead you down the wrong path, even though you did all the right work. So, here we go. And on the bottom, check solutions. Can't take logs of negatives. I have it on this slide. I should have put it on the last slide. Because, here we go. Oh no, the dreaded x squared. Yes, guys, we will have to go back and you will have to remember how to factor, take square roots, all of those things that you guys have been doing since Algebra 1 and Algebra 2. And so they're coming back to haunt you if you did not do your work then. Again, I got log base 5 of x squared equals log base 5 of 4. The logs, the logs technically cancel each other out, and I get x squared equals 4. And you guys are like, hey, actually, this isn't too bad on this one. You very well could form a quadratic, so you may have to factor, set it equal to 0 and those things. So we could do that both ways. I think the easiest way, obviously, is to take the square root of both sides. Don't forget that when you're square rooting and solving for a variable, that you have to have plus or minus, so x equals plus or minus 2. Well, guess what? We know that if I take those answers of positive 2 and negative 2 and I plug it here, therefore I will have, actually, I'm going to have 2 squared, so log base 5 of 2 squared, which is really log base 5 of 4, and that works because that actually equals over here. We also have log base 5 of negative 2 squared, and that would actually equal, oh wait, that's the same number. So both of those answers will work. Not like the example from the last page where when I plugged that number in, it became negative. So in this case, both work. I had 2 solutions, both work. Other times, it will not. Also, if you didn't like the fact that I took the square root, could I not have done this? Brought the 4 to the left side, bringing it to all one side, and now you're looking at that going, wait, that looks really familiar. That is the difference of squares. And so I end up factoring. Those factors will eventually be set equal to 0. Difference of squares, it's x minus 2 and x plus 2, and that would lead us to our answers of x equals 2, x equals negative 2. I'm sorry, those are starting to get squished into there. But that is factoring technique. Some of them are going to be regular quadratics where you have to worry about a or not have to worry about a. Sometimes we got difference of squares. Sometimes you will have other techniques that you will have to use. So keep that in mind as you're picking and choosing your homework. Yes, we'll have homework. Go back to that same log packet that we've been working on. Yes, that's a lot of problems, 81 through 120. You do not have to do them all. If you want, go ahead. But I want you to do just 10 problems out of all of those 40. So do like every 4th problem. So please, just like before, do not do the first 10 problems and call it a day. You will not be exposed to all the different types of solving so that when you guys get any kind of assessment, you guys will know what's going on. So remember, there is a check-in tomorrow. We're doing the check-in with the same base equations. That was the solving the exponents. Problems 1 through 20 on this particular packet, and the condensing logs. Joke, I think that was. Otherwise, have a great day.